Hi everyone, welcome to Go Classes and also welcome to our new course which is C programming. So in this particular video, we will see introduction to C programming and why we require it, right? So before we go to these two words which are separate, which means C and programming. Combined you call it C programming, but I want to look at these two words as a separate words. So let's just first see that what is this programming and why we need it. So just imagine that these are the two persons. Like just assume that this is me, maybe. Okay. So this is me and this is you. And suppose we both want to communicate. If we both want to communicate, and if I want to communicate something to you, then I may be communicating to you in some native language or maybe English or Hindi or something like that, right? So some human understandable language, I will be in that language I will be communicating to you. So maybe that language could be English, maybe that language could be Hindi, based on whatever language we both are comfortable in. So if we both are comfortable in English, I will communicate the same thing in English. If both are comfortable in Hindi, then I will communicate the same thing in Hindi. Now you will get to understand what we are what I am saying actually, right? So this is the way of communication between two humans. Because I am human, you are also human, right? Now suppose that instead of two humans, I want to communicate something to the computer, right? So I want let's suppose I want to say something to the computer, maybe some mental kind of work I want to perform to this computer, which means some mental computation that could have been performed using the human, but instead of human, I want this computer to do my task. For example, in earlier case, maybe I will say that can you add these two numbers? Okay, maybe I will ask you to can you add these two numbers? Can you add two numbers? I will ask you something like this. Okay. I mean some mathematical computation that I may ask you in this case, right? Now, for example, let's suppose that instead of you, I am asking the same thing to the computer, which is I'm saying that can you add two numbers to the computer, right? So this time I'm saying the same thing to the computer, which is can you add two numbers. Now, can I say that directly in English? That can you add two numbers? Obviously no, because computers doesn't understand English or Hindi. I mean, they can understand. You can write the programs on top of that, but it is better if you basically communicate in the language that computer understand. So earlier I can communicate in English or Hindi because you also understand English Hindi. I also understand English Hindi, so I can communicate some task to you in English or Hindi. But in this case, I cannot communicate in either English or Hindi directly, right? So there is some language that in that way I should be communicating to the computer because that language should be understood by the computers. So computers doesn't understand English or Hindi directly. So that's why we need to communicate something using something called programs. Okay. So I need to communicate that can you add these two numbers using a program. So what is a program and and how to communicate using a program? These are the two questions, right? So just imagine that I want to perform some task. Maybe let's suppose, let me just take a simple task, maybe add two numbers or finding the average of few numbers or something like that, right? So let's suppose that I take a simple task which is finding the average of few numbers. And then I have few numbers, let's suppose x1, x2, x3, okay, or x4. These are the few numbers I have. I want the computer to perform the computation which is like this: x1 plus x2 plus x3 by 4. So what can I do here? I will say to the computer, I will say that okay, what you need to do, you need to add these numbers, right? I mean, I will tell the procedure, which is basically looking like this. Maybe I will say to the computer that okay, add all the numbers, add four numbers, divide by 4, and output. So basically these are the set of steps that I can tell to the computer that okay, do perform these steps, right? These are the set of steps. But again, computer doesn't understand this English language, that what are these steps and all. So I have to convert that English language or the set of steps into something called program. So I will give a program to the computer that the computer will understand. Now, this set of steps that I'm giving to the computer are called algorithm. I mean, they could be in the English language, they could be in the pseudocode, they could be in the flowchart. So, what I'm saying that these are the set of steps that I have, right? Set of steps. These set of steps are called algorithms. Algorithm. So, the algorithm means that I'm basically currently I'm putting a loose definition, and when we go to the algorithm, then I will tell you the formal definition. I will talk about the rigorous definition of algorithm later, but for now just understand that algorithm is a set of steps that could be in English or Hindi, right? I mean, or any other language that you have preferred, or that could be in the terms of something called flowchart, that I will say that okay, do this, something like this. That could be in the pseudocode format. Pseudocode means the partial code which tells that okay, you can convert that to a program. So basically it is in a sense I can say that it is some informal way of describing the steps, right? Informal way of describing the steps. And then what we do, like for example, this is the set of steps that we have. Then what we do, we convert those set of steps into something called as I just told you, into something called as a program, right? So what we will be doing, we will be converting these set of steps into the program. So these are the set of steps that I have, which are called algorithm. And now we will be converting these set of steps, that whatever we have, into something called as program. And how does the program look like? It will depend on the language. So if it is C language, maybe I can say that okay, there might be some for loop that is adding some numbers, then you are basically sum plus equal to I or something like that, or xi, and then you are basically returning that sum or something like that. I mean, it will depend on the language that we are interested in. Now you understood something, which is that there is an informal way of telling, which is called algorithm, and then converting that informal way to a formal procedure is called program. Now, just like that, if I'm communicating to a human, then there are multiple languages possible, which are English or Hindi or something like that, right? Similarly, if I want to communicate to the computer, then again there are multiple languages possible. So if I want to communicate to the computer, then I have to communicate using a program, right? Now let me go back to this particular diagram. So what I'm saying here is that if this is me, and if I want to communicate something to the computer, then I have to communicate using a program. Now again, if I'm giving a program, then again there are multiple languages that are possible with this program. You can write your program into C language. I mean, this is one possible language. You can write in Java, you can write in C++, you can write in Python, and there are multiple other languages possible, right? So if you want to communicate your set of instructions and whatever you want this computer to do, if you want to communicate, then there are multiple languages possible. Just like if you want to communicate something to a human, then also there are multiple human languages possible. Similarly, these are called computer languages, right? Maybe C language, Java, C++, Python. So now you got to understand that why we need C language. So what is the answer that why we need C language? Why we need C language? The answer is that we want computer to perform some tasks. That's all. And we want to communicate to the computer basically, right? So you can say we want to communicate to the computer. So that's where we require this C language. Now there are multiple other subjects actually, like in this particular video I want to talk about, maybe in a brief I want to talk about all the subjects that we have. So why we study all the subjects that we have in GATE computer science syllabus, which means that, I mean, what are the practical practical significance of all of these subjects. So let me quickly tell you about the practical significance. Which means how they are making our life better, all the subjects. So this is the GATE computer science syllabus, which are like programming in C, data structures, algorithms, compiler design, operating system, and these all the subjects. Let's quickly see that why we need all of these subjects in combo. So let's just first talk about this first set of subjects, which are programming in C, algorithms, and all, right? So let me first talk about these three subjects. So now I hope this is clear that why we need programming in C, because we want to communicate something to the computer. That's why we need the programming, and that could be in the C, that could be in Java, that could be in any other language. But in our syllabus, we just start with C programming. Okay, so we want to communicate to the computer. That is clear. Why we need data structures and algorithms? What do you think? Yeah, currently I know that you might even not be knowing that what is data structure, what is algorithm. But let me just give you, as I said, let me just give you the brief introduction that why we need all of these subjects. So see, if you have a problem in your hand, then you might want to solve it. And not just you want to solve it, you want to solve it efficiently, right? So we want to solve problems efficiently. Now, currently it might not be 100% clear to you that what does this efficiency mean, but it will get clear when we see algorithms. So this is where we need algorithms. This is where we need actually that how to analyze the algorithms, that whether my algorithm is taking too much time or too less time, or what is the significance of this algorithm, right? Is this algorithm correct? So the correctness of the algorithm, right? That's where we will study the algorithm subject. The different ways to solve a problem, that's where we will be needing the algorithm subject. So is my algorithm correct? This is where we need this algorithm subject. Different ways to solve a single problem, right? Different ways to solve a problem. Like for example, let me just give you the example. You might have heard about it. There is something called sorting, right? If you want to sort few numbers, this is called a problem, and you can solve this problem using multiple ways. Maybe you can have merge sort, right? You can have maybe quick sort or like that, right? So there are multiple ways to solve a particular problem, and these are called algorithms, right? See, sorting is one name which is called a problem, but the specific algorithms are called algorithms, basically like specific techniques, algorithms. These are the algorithms, right? Now you might want to solve it using different ways, or you want to analyze your algorithm or like that. That's where we need algorithms. Then why we need this data structure at all? See, to implement algorithm, there are data structures which are needed, like array, heap, hashing, or some other data structure you might be needing, right? Linked list, like that. So that's where we need data structures, because we want to implement the algorithms, and there we will be needing the data structures. We want to implement algorithms using data structures, right? Okay, so that's where we need these three subjects. Cool. Now let's just come to other pool of subjects, which are let me say the compiler design and operating system and all, right? So let me go to the next page, and let me just talk about that why we need all other subjects which are like that, which are let's talk about these set of subjects, which are compiler design, operating system, computer architecture, and digital logic. See, what happens when you write a program, then I will talk about these things in a detail, okay, in our C programming course itself. Like if you have seen the last year programming course, then you might know it, that we will talk about it in detail. But anyway, in a brief, let me just talk about it. So when you write a program, this is in a text editor, right? So this is just maybe .c, .java, .txt, whatever it is, right? So it is in a text editor. That's what I want to say. Now what you need to do, you need to basically check whether this program is correctly written, the syntax and all, and everything is fine or not. So where you will be needing something called as compiler. And once you compile your program, again, that's in the hard disk, which is called a.out or a.exe or whatever. I mean, it depends on the platform on which you are running. If you're running on Linux, then it will be a.out. If you are running on Windows, it will be a.exe or something like that, right? Cool. Now, again, it is in the hard disk in the sense that you have stored it. It's not currently running. Okay, currently not running. So you can say that this is currently not running. But this is a executable file in the sense that if you want, you can run it directly. Okay, so that's where you need the compiler. Compiler will check whether all the things are it's for like a sanity check, whether all the things are fine or not, whether this program is runnable or not, or you can you have written you have followed the correct syntax or not, whether what you want to communicate is understood will be understood by the computer or not. So that's all the things will be checked by the compiler. So that's why we need the compiler design subject, right? Now once you have this file with you, that has to be run. Currently it's not running. As I said, currently it's not running. That has to be run, which means this should be running in something in something called as memory, right? I mean, you will get to understand the memory little later, but yeah, that has to be loaded into the memory. So you can say it has to be loaded. There is something called a loading. So it has to be loaded in memory. Now, since there might be multiple programs running in the memory, then you have to determine that in which part of the memory it should be loading, right? If it is memory, then in which part? Maybe you are using paging, which means you may divide that program into the pages, and then you will be loading into the different parts or something like that. I mean, you will get to understand this paging and all later. But yeah, let's suppose that you are loading it here at a contiguous location, okay, and you are not doing paging or something. Anyway, like you will get to understand this later. So you are loading, let's suppose, this here. Now there has to be some software which manages all of this memory, and there are many other resources. Maybe this program wants to use printer, maybe this program wants to use some other resource, and there are certain things that you want to do repeatedly. Repeatedly means that it's not a one-time job. It's not a once in lifetime that you are doing, right? I mean, you are running the programs, maybe 2-3 programs daily. Or maybe if I look at the wide range of people, then there are millions and billions of people which are running their programs on the computer daily. So what we have done, we have actually created a software called operating system. Since we are doing it daily often, right, then why not to create a software which is helping us to do all of this. And that's where the operating system comes into the picture, that manages the memory, that where to load the program and all. So we will see the need of operating system explicitly in the operating system course. The first lecture will be the motivation to the operating system, then why we at all need the operating system. That we will see in the operating system course later. But for now, just understand that we want to load that into memory. We want to manage the resources like memory, printer, and all, right? So that's where we need the operating system, because at the end we want to manage some resources. Okay, so all of this is fine, like you are running the programs and all of this is fine, but all of this is a software component, right? I mean, you have written the compiler, you have written your operating system, but all of this is a software component. But at the end of day, everything is running on the hardware. Everything is running on the computer. Your ALU, your memory, everything is interconnected, data bus, address bus. So this is a huge chunk of hardware components which are interconnected to each other. So we need to understand that how all of these are working together, which means how memory is linked to CPU, how CPU is linked to IO controller, or like that. IO controller means the printer and other resources. So basically, these are the hardware components which are interlinked to each other, and that's where we need the computer organization subject, where you will get to understand that how all of these hardware are connected to each other. Now, we also need to understand that if you go to one level down, then you will get to see that all of this are basically made of transistors, made of flip-flops, made of gates like AND gate, NOT gate, like that, right? So all of this is at the end of day hardware circuit. So that's why, like, if I look at the memory more closely, maybe it is made of flip-flops, right? So at the end of the day, I need to understand that how these all hardware components are even built upon. So that's where we need the digital logic subject, right? The adders, the subtractors, all of these are hardware component. So that's where we need the digital logic subjects. So these are the system subjects that we need to understand to to basically understand the fundamentals of computer science. Now, let me just go to the different pool of subjects that we have. So, I hope you understood that why we need these. Now, let me go to the other different pool of subjects. So, let's just talk about the other subjects like maybe DBMS and computer networks. So, what do you think why we need DBMS and these computer networks? See, like till now what we have just seen is basically the components of computer, which means like why we require all of these subjects, all of these basic subjects is because like we need to understand the computer, we need to run something on the computer. But as the users are increasing, as the data is increasing, we have a huge chunk of data nowadays, right? So we need to manage our data, we need to query our data, which means there should be some structured way to manage our data, and that's where we need DBMS system, database management. So it is like a structured way to manage our data. We need to query our data, which means we need some languages like SQL and all. We need to understand that how all of these tables are interconnected. I mean the database tables. There we will be needing the relational algebra, ER diagrams and all, right? Relational average algebra. We need to understand that okay, if someone is doing a transaction and then if the transaction is getting failed and all, if multiple transactions are happening at the same time, so we need the transaction management and all. So basically we have a massive amount of data and we want to manage that data. So that's where we need to understand the fundamentals of databases, right? And that's why we need the database management system. And what about this computer networks? Why we need this computer network subject? So we need this subject to interconnect or to communicate the information from one computer to another computer. So if we have multiple computers even, then also we can work with the multiple computer networks, which means that we have many computers to work with and then we can make a network out of it. So that's where we need the computer network subject. So because we can communicate among multiple computers, right? Multiple machines, you can say in general. Okay, now let's just see why we need these subjects like theory of computation, why we need the discrete mathematics, why we need engineering mathematics, these kind of courses, right? So why we need theory of computation, discrete mathematics? See, theory of computation is one subject that will tell you that that will basically tell you this is a theoretical subject, but it will tell you the limitations of the computer, the expansion of the problems, the type of problems and the limitations of the computer. So it will tell you limitations of computer or the possibilities of the computer. What the computer can do, what the computer cannot do, right? Possibilities of the computer. The types of problems, what are the different types of problems that computer can solve, and even what are the different type of problems that exist in the world, the type of problems and everything. So that's where we need the theory of computation, where we will actually get to understand the limitations of the computer and the possibilities of the computer. And why we need discrete mathematics? So discrete mathematics is actually needed to understand the basic logic behind everything. So it is just like aptitude kind of subject where you get to understand like the basic things. Basically you can communicate to someone in a mathematical way, which means if you want to communicate, if you want to have reasoning, then you have the mathematical logic, the first order logic here. If you want to communicate something to someone, then you can represent your ideas in the set notation, if you want, right? So you have set theory here, you have graph theory. So it is a kind of aptitude kind of subject where you will be needing this subject everywhere, and this is most crucial subject, and that's why we just study this subject as the first subject in Go classes. Okay, last but not least, that why we need engineering mathematics. So I think you might already be knowing that engineering mathematics is very, very crucial for the machine learning. So if you want to do any machine learning operation, then it is better to know the engineering mathematics. Why? Because everything, like whatever I say, so if you recall from my linear algebra lectures, so whatever we have, whatever kind of data we have, it's in the matrix, right? Whether it is text data or any audio data, video data, everything can be converted to the matrix that we have already talked in the linear algebra course. So everything is in a matrix. So if you want to process the data, you need to know the properties of this matrix. You need to know that how you can utilize this matrix. You need to know the tools of linear algebra. and this data might be following some probability distribution. So that's why we need the probability here, because this data, whatever the data we have, that might be following some probability distribution. So that's why we need the probability here. And at the end of the day, we want to optimize something. So that's why we need the calculus here. Anyway, like we cannot talk about these things in more detail, but I hope you are getting something. See, we need linear algebra. We need linear algebra because everything is matrix. Everything means data, right? Every data is in matrix, Data follows some probability distribution. That's why we need the probability, right? Data follows probability distribution. And we need calculus also, because we want to optimize something. Because at the end of the day, there are something called loss function. I mean, loss function in the sense that there is some ideal number that we want, and there is some approximate number we want, and we want to basically get closer and closer to the ideal. So that's called the optimization, and that's where we need this calculus. I mean, this is just one application of the calculus. So that's why we will be needing the engineering mathematics. And I can say that all of these subjects are very, very crucial to understand if you want to really understand the computer science, right? See, you now know the importance of all of these subjects, why we need all of these subjects. In a summary, I can say that I need the programming because I want to communicate something to the computer, but I want to communicate in the efficient way. That's why I need the algorithms, and to write the algorithms, I need the data structure. Now, when you write the program, it's in the text editor. You want to compile it. That's where you need the compiler design. And you want to finally load it in the main memory. That's why you need the operating system. But you also want to understand the different components of the computer. That's where you need the computer organization. And at the end of the day, everything is built upon the flip-flops and transistors. So that's why you need the digital logic subject. And database is one auxiliary subject in the sense that you have the massive amount of data and you want to manage that data. Then there should be some structured way to understand the data. That's where we need the database management systems. Component networks is basically to communicate between multiple computers. Theory of computation is basically a subject that tells you the limitation and the possibilities of the computer. Discrete mathematics is one very logical subject that you will be needing to basically understand different logics. Engineering mathematics is very crucial for the machine learning. So that's the summary of all the subjects I can say. Now, just to summarize, I can say that after this GATE CSE preparation, you will get to know what a smart computer science student knows. So this is all about GATE computer science preparation. I hope I conveyed you that why we need all of these subjects. Yeah. So that is all for this video. And from the next videos, we will be starting with our programming in C. So this is just a motivation to why we need the programs, and like we have not limited our discussion to only just one subject, that why we need it. Yeah, but we talked about all of these subjects. But anyway, like whenever we start any subject like engineering mathematics or the operating system, or whenever we start any subject, then we always tell the motivation that why we are studying the subject, right? So this is just a brief introduction that why we are needing all of these subjects, but at a particular subject, we will go deeper and we will get to understand that why we need that subject particularly, right? Okay. So thank you so much. Thank you everyone. Take care. Bye bye.